Good afternoon, everyone. Thank you for joining us today. My name is Ilona Pawełoszek. Together with my colleague Cezary Stępniak, I'm excited to present our research on abstract space visualization for regional development. We will share the key findings from our research, show the prototype of an abstract map, and discuss how we can leverage this tool to support regional development. The technology of electronic maps has been in use since 1950s. Its application has led to advanced geographical information systems. Electronic maps are widely used in social, economic, and scientific fields. They have become essential tools for planning and implementing various projects. Recently, electronic maps have been enhanced with computer animations, augmented reality, digital twins, and artificial intelligence. At the same time, modern societies are struggling with an excess of generated data, which limits the ability of individual users to perceive it. Therefore, there is a growing need to seek new types of tools that would facilitate understanding of the collected data. This article introduces an innovative concept, a visualization tool based on abstract spaces named AMC, Abstract Map Creator. The notion of space is now expanding beyond geographical meaning, encompassing information space, social space, political, educational, and many others. Just as maps changed our understanding of geographical spaces, our tool aims to do the same for abstract spaces. To show AMC's potential, we focus on a specific environment, the management of projects in a selected region of our country, Poland. The concept of abstract space can be defined and understood in various contexts, particularly mathematics. An abstract space often refers to a set studied abstractly without necessarily referring to real-world geometric properties. In mathematics, these are topological, vector, and metric spaces. In this discussion, abstract spaces are intended to visualize phenomena occurring in the real world, but not according to geographical locations. Mapping abstract spaces requires converting concepts not inherently visual or spatial into a graphical representation. Although many of these objects to be visualized could be presented on geographical maps, such maps would not reflect the true purpose of the visualization. Let's imagine the abstract space of human personal relationships, which may not depend on geographical distance. On an abstract map, both geographical coordinates and abstract coordinates can be assigned as their spatial attributes. As a result, geographical maps can be linked with abstract maps. The primary challenge is defining useful abstract space, finding rules that allow objects to be placed accurately on abstract maps. For this, we need to realize the purpose of the map, what is the most important to show, dimensions of space, types of objects, and characteristics of a space. Abstract spaces define non-physical areas encompassing concepts, objects, events, or processes. When creating dimensions, they need to follow certain rules of continuity, unambiguity, and stability. A single dimension can be made up of different parts, where each part is unique and doesn't overlap with the others. Together, all these parts fit together perfectly to form the entire dimension. Sub-elements must follow a strict order. Typically, at least 2 dimensions are used, or one may be time. Visualization is usually limited to 3 dimensions. Abstract spaces reflect subjective perceptions of reality by the designer or user. We start with heuristic methods to develop common sense principles, and these principles can be mathematically described, especially when we want to code them as a computer algorithm. For our case study, we selected northern sub-region of the Silesian Voivodeship, Poland. Our focus was to visualize regional strategy development and the needs of the inhabitants. The dimensions we defined are population distribution and national strategic goals. We used heuristic methods to develop algorithms for defining and standardizing dimensions. We used the project data from public assets. We aim to visualize regional management projects where X dimension represents population across regions. X dimension is divided into city districts and counties with further division into villages. Y dimension represents goals and sub-goals. Projects are placed on the map according to the administrative unit they are implemented for and strategic goals. There are many special visualization tools available. At first, we tried a bubble chart with two categorical axes. This was developed in Python, but this visualization doesn't meet our requirements. The points are overlapping. It was not possible to change the interval on x-axis to represent the population of administrative units and to show the unit category, city or village. So we defined the dimensions. In the given example, there were 271 projects to manage within the sub-region. For this example, we limited the number of projects for the map to be more readable. Our goal is to allocate these projects on the map created by the dimensions. This involves determining the project's location within the space and then selecting the method of symbolization. This is the table which represents the data structure we used for the abstract map creator algorithm. It contains three tables. The first one is X dimension, table describing administrative units, their population and type. The second table describes the goals, where a unique identifier for each development direction indicates a strategic goal and sub-goal. The table also contains the start and end points on the y-axis to define the space on the map each goal occupies. The third table is project data. Each project is linked to the goal identifier, specifying under which strategic goal, sub-goal and development direction the project falls. This is our prototype visualization. On an x-axis, we can see the administrative units according to their population and type, city or village. Y-axis represents the strategic goals. In practice, we could zoom in to see the sub-goals and development directions, but here they are omitted to maintain clarity. The circles on the map represent projects, their size is the financial value, and the color represents duration of a project in years. Of course, we could choose other symbolization. There is no problem to change the meaning of colors and size. Discussing the requirements with a public administration representative, we identified the requirements for AMC. The tool should provide access to the largest possible amount of data with the possibility of choosing interesting views. There is a need for quickly browsing projects based on specified criteria. The tool should enable quick access to documentation for projects meeting the specified criteria. The tool should be comprehensive and integrated with other IT systems containing related data. To implement the AMC, we need to develop a user-friendly software package integrated with other systems. For this, we will need the help of special engineers who will define new types of useful abstract spaces. Primary skills should be the ability to think abstractly and use heuristic methods considering the end user's needs. Discussion with public administration representatives indicated that AMC is interesting. and potentially useful. The integration of AMC with GIS technologies and other ICT systems could lead to more informed decision making, improved transparency, and greater accountability in regional management. Our future research will focus on the tool's practical implementation, including the development of user-friendly software interface and the robust data integration protocols.